And the SPY client is written so well, and the Danga client is so hacky and so bad. But the SPY client uses a lot of concurrent stuff, and it basically keeps a thread to sort of do all the memcache work. And you throw data into a queue, and the thread's doing the work. But the way we structure our servers is this massive JVM, so we can't benefit from that because we completely overwhelm the thread. And we actually, when initially, we said, oh yeah, we're doing all this work. Let's look at going to the SPY client. So we made this abstraction layer between memcache clients, switched out to the SPY, and the entire website, or we didn't roll it out completely, but the servers that were running SPY ground to a halt. Actually, I have another funny little scaling story. So again, this is what we say. You need to figure out what your problem is before you solve the problem. So we were doing a bunch of thread dumps on the production servers because eventually they would run fine, and then they'd just stop, and they would be completely locked up. And we were doing thread dumps at a frequency where right before one locked up, we finally got a good thread dump. We found that we had just upgraded to Java 1.6, and we immediately saw a 20% improvement in throughput on all the servers, and going to memcache, it was amazing, just by upgrading the JVM. They made a huge improvement with serialization. But what we found was there was contention in a reference queue. And what happened was Sun never ported a fix to Java 1.5 to Java 1.6. So what we had to do was find the reference key from Java 1.5 and use that same class file and bring it to 1.6, and that solved the problem.
Submit a bug.
I did submit it. The bug was rejected. Yeah, apparently they don't want to fix it. I saw your hand first.
Can you talk about, the whole panel maybe, about sort of testing strategies? In my experience, it's very, very difficult to get realistic load testing, and you almost always end up sort of rolling it out into a tiny portion of your production environment. Do you guys have
completely accurate? No, there's no. I've not found a magic bullet for testing under load.
No, I don't think there's a magic bullet. I mean, it depends. I mean, again, it really depends on kind of what architecture you're using. So I think kind of the different strategies depend from like language to language, platform to platform. There's actually some, Rasmus Erdorf did some really good stuff about how to do this with PHP. But yeah, I mean, from my experience at Yahoo, I worked on the Yahoo front page for about 3 years, and we would, sort of look at something's happening. Well, let's look at it during peak load and see if we can figure out what's happening, because it's going to be happening a whole lot more during peak load. Yeah. But yeah, there's no magic bullet.
We've actually used a couple of strategies to instrument builds that we put out, and we put instrumented builds on some of the servers. And we don't do this on a lot of servers. We haven't been doing it for very long because the build spit out about 150 megabytes per minute. And
do you bucket?
Huh?
Do you bucket? Do you put people in? Do you put like a percentage of users into a?
Yeah, we have a load balancer in front of everything, so we can kind of reduce the load on the servers. And then we're using Hadoop to sort of sort through the logs, and I have a Ruby-based interactive shell that I can ask questions of the logs after they've been parsed correctly. And that's been a big help. It's really eye-opening to see your servers run in prod, and maybe dtrace. Actually, I've heard a lot of good things about dtrace. That could probably help and sort of do that for you, rather than having to use like AOP and code instrumentation.
I mean, I think it depends as well, because one of the tools that I think we found really helpful is recording sort of like live user sessions and then playing them back on offline boxes. That's actually a really good tool, because the problem is if you've got test suites, they don't necessarily always do the same kind of behaviors as users. So if you can kind of record like the session traffic you got from users and then replay that back onto a development machine, then you've got a much better chance of kind of finding the particular hole that the user sort of stuck their stick into to break your system.
The other way I've seen it done is you have an application in the back end that actually monitoring the traffic, monitoring the user behavior and such. And so when you roll out the features, again, you've got to roll it out live. That's why all the web to the sites that go themselves internal beta, they never go live. But what happens is in some of the cases I've seen this backend application was like implemented in Java. It just doesn't matter really. It just detects, denial of service attack, detects when user behavior, it causes performance degradation, particularly under the heavy load, and that analytics sort of was used to improve the performance or maybe modify the way how you are sharding your data. So that sort of stuff is very useful.
Yeah. We have the same thing. It's called Sauron. It's back there, and the big eye monitors everything. It was built for the apps platform, and the reason was there are certain queries that we have a query language much like Yahoo, FQL, that's the same sort of thing. And there's certain queries where just the structure of our database tables, if a user constructed a query in a certain way and started hitting us with it, it would really take down our database. And we wanted to make sure that wouldn't happen. And if it did happen, we'd shut off their API key as quickly as possible. And the best way to do that is to have this watchful eye in the background.
Have you tried Splunk at all?
Splunk is really expensive, especially when you have this sort of. Actually, we have.
Do you think like in dollar value or is it resource?
Dollar value.
Yeah, we're looking at that. It's pricey.
Yeah, it is. And the more data, and it's the worst thing. I mean, what you want is you want to know as much about it, what your application is doing as possible, and that generates more data. And the more data you generate, the more expensive Splunk is. So it's sort of this.
But I think it's kind of, I mean, at the same time, data is good, but it's about having like the right data. So, you know, unless you're hitting a wall where you really need
You can always pare it down.
Yeah, exactly. Like start like basic and kind of, you know, do like some really obvious things. I mean, if you're not already doing it, you know, just like fire up curl on cron and just like, you know, smack a development server and just kind of see what it's doing, and you can do a lot more. Yeah, exactly. Throw debug on, you know, really basic stuff like that. If you're not doing it already, then, you know, trying to work out how you debug production, there's no point. You know, start simple and then work up.
Yeah. Is Python used much in scalable systems, like with a MapReduce library, or is that pretty much a role for Java?
Well, honestly, if I was writing a MapReduce program, I'd rather write it in Python.
So there's something called Dumbo, which is a Python wrapper for Hadoop. So if you want to do MapReduce, you can use Dumbo, and it basically I think it uses Jython, I think, to basically just allow you to write Hadoop programs in Python.
You can also use Hadoop streaming too, right?
Yeah, you can use streaming as well.
What was
Streaming's
the name
pretty
of the
cool. Dumbo.
Dumbo?
Yeah, like the elephant.
Yeah, all the Hadoop libraries are elephant-based. Mahot, Dumbo.
I'd like actually more information on the instrumented builds. Where could I?
Sure.
Is there reference material? Or how can I get started doing that?
It's actually, what's your